In this video, we are going to concentrate on adding and subtracting radical expressions. So the first thing I want to tell you is that it's a lot like dealing with like terms. You cannot add and subtract them if they don't look the same. So for example, the same way 3x plus 2x equals 5x, because they both have the x. That's what makes them like terms. Over here, we have square root of 7 plus 2 square root of 7 minus 9 square root of 7. Since they all have the square root of 7, that does make them the same. So technically, there is a 1 here. So I know that if I put these together, I get 3 square root of 7. Bring that one down. And then I can do 3 minus 9 square root of 7 because they are also like terms. And that would be my final answer. With the second one, it's the same rule. I'm just showing you higher roots, meaning this is the fourth root, but they do still match. They both have the index of 4. They both have the radical of 5y, so they are the same. Again, this is like a positive 1. So it's like 1 minus 6. So you get negative 5, the fourth root of 5y. Let's do a couple more because they're not always the same when you start out. Sometimes when you're given the problem, they're not like radicals and you have to try to simplify them so that possibly they become like radicals. So with this example, I'm looking at the square root of 12. 12 is not a perfect square, but I can simplify it into 4 times 3. And I like that combination because I can take the square root of 4 and get 2. And I'm just going to leave the square root of 3 because I can't do anything else with it. The 27, I can also break that up into 9 times 3. And I also like that pair because at least I can take the square root of 9 to get 3. And then the square root of 3 stays. So note, once you take the square root of something, it gets kicked out to the front. So last but not least, the square root of 48 would be 16 times 3. So what is the square root of 16? It's 4. So minus 4 square root of 3. Now just by chance, this doesn't always happen this way. All of the simplified answers are also like radicals because they all have the square root of 3. So these two give me 5 square root of 3 and then minus 4. So I get a 1 square root of 3. And we're just going to keep doing the same thing. Sometimes it's not just the number that you have to simplify, but it's also the variable with exponents. So for example, my index here is a 2, right? When it's invisible, I know that it's a 2. So 50 is going to get broken up into 25 times 2. And x to the 7th, I want to break it down to the closest even number. So I'm going to go x to the 6th and then the leftover one because that still makes it 7. Then I'm going to come over here and 32 is going to become 16 times 2, where x to the 5th is going to break down to 4 and 1. Again, whenever you're taking the square root of the variables with the exponents, you always want that closest even number. So the square root of 25 is 5. The square root of x to the 6th is x cubed because you're literally just dividing by 2. And then what's left is the 2x. With this next one, the square root of 16 is 4. So that's going to get kicked out here. So I'm going to end up with negative 4x. Square root of x to the 4th is x squared. So when the x squared comes out here and joins this x, it actually becomes a 3. And then I'm left with the square root of 2x. So again, by chance, not only are my radicals the same, but my coefficients are also like terms, which is good. 5x cubed minus 4x cubed leaves me with 1x cubed. And then, of course, the square root of 2x, which is what makes the terms the same. We have a couple more examples we're going to work on. The square root of 72 minus 13. Square root of 72, I can definitely break that up into 36 times 2. 13, unfortunately, there are no factors that are perfect embedded in that number. Square root of 36 is 6. Got the 2. Now, unfortunately, this one, when I simplified it, there were no like terms. So that is your final answer for that one. This last one is another example of higher order roots. These are cubic roots, right? The cube root. They do all match though. They are all the cube root of 5. So we're going to go ahead and put the coefficients together. -2, -9, and -13. So 9 and 2 is going to give me -11. And then -11 and -13 will give me -24 cube root of 5.